Thank you for joining us. Our show today will focus on how scientific progress and research worldwide is leading to breakthroughs in everything from technology and energy to medicine and health, which includes addressing the diseases of aging. From nutrition to CRISPR-Cas9 gene editing, we are witnessing numerous promising developments, and Bill Faloon, the founder of the Age Reversal Project, will update us on these essential subjects following these messages.
Human age reversal. We may be there already. Human studies are now ready to begin to confirm meaningful reversal of pathological aging processes. These clinical trials aim to alter older humans so that they function as much younger individuals. Even modest success will result in a paradigm shift that will impart enormous societal benefits, such as sparing Medicare from insolvency. Life extension is not standing idle while 5,000 Americans die each day from age-related illnesses. Joining us are physician scientists who want to hurry up these technologies to keep people from aging to death. While life extension is pushing these projects forward, we need financial help to ensure these studies are carried through to fruition.
Carrier asks, what does comfort mean to you? Is it a cool breeze on a scorching day? Or a cozy corner on a cold night? That every room of the house is as inviting as the next. And the air is fresh and clean for everyone. That humidity is where it belongs. At Carrier, comfort means more than just the temperature. And the people who invented modern air conditioning keep inventing new ways to make you comfortable, however you define it.
Find magic again. Sprout by HP. With Intel RealSense technology inside, now you can bend the rules of creativity outside.
The CRISPR-Cas9 system is a tool for cutting DNA at a specifically targeted location. The technique has already revolutionized gene editing, but scientists are always looking for new possibilities. So what else can CRISPR do? Since being discovered in a bacterial immune system, CRISPR-Cas9 has been adapted into a powerful tool for genomic research. There are two components to the system: a DNA cutting protein called CAS9 and an RNA molecule known as the guide RNA. Bound together, they form a complex that can identify and cut specific sections of DNA. First, Cas9 has to locate and bind to a common sequence in the genome called a PAM. Once the PAM is bound, the guide RNA unwinds part of the double helix. The RNA strand is designed to match and bind a particular sequence in the DNA. Once it's found the correct sequence, Cas9 can cut the DNA. Its two nuclease domains each make a nick, leading to a double-strand break. Although the cell will try to repair this break, the fixing process is error-prone and often inadvertently introduces mutations that disable the gene. This makes CRISPR a great tool for knocking out specific genes. But making double-strand breaks isn't all CRISPR can do. Some researchers are deactivating one or both of Cas9's cutting domains and fusing new enzymes onto the protein. Cas9 can then be used to transport those enzymes to a specific DNA sequence. In one example, CAS9 is fused to an enzyme, a deaminase, which mutates specific DNA bases, eventually replacing cytidine with thymidine. This kind of precise gene editing means you could turn a disease-causing mutation into a healthy version of the gene, or introduce a stop codon at a specific place. But it's not all about gene editing. Several labs have been working on ways to use CRISPR to promote gene transcription. They do this by deactivating CAS9 completely, so it can no longer cut DNA. Instead, transcriptional activators are added to the CAS9 by either fusing them directly or via a string of peptides. Alternatively, the activators can be recruited to the guide RNA instead. These activators recruit the cell's transcription machinery, bringing RNA polymerase and other factors to the target, and increasing transcription of that gene. The same principle applies to gene silencing. A CRAB domain fused to the Cas9 inactivates transcription by recruiting more factors that physically block the gene. A more outside-the-box idea for using CRISPR is to attach fluorescent proteins to the complex, so you can see where particular DNA sequences are found in the cell. This could be useful for things like visualizing the 3D architecture of the genome, or to paint an entire chromosome and follow its position in the nucleus. CRISPR has already changed the face of research, but these new ideas show that what's been achieved so far could just be the tip of the iceberg when it comes to CRISPR's potential. Whatever comes next, it seems the CRISPR revolution is far from over.
4 years ago, there was a charitable organization that made a presentation about reversing Alzheimer's disease. Now, if you pick up any peer-reviewed publication today, or a lay magazine, a newspaper, they will open up by stating Alzheimer's only goes in one direction. You become progressively more demented until you lose functionality, you turn into a vegetable, linger a few years in a nursing home, and die. 4 years ago, an irrefutable evidence was presented showing that early-stage Alzheimer's disease and mild cognitive impairment that often precedes Alzheimer's is reversible. This was a charitable group. They had no money to make. They had no magic potion. They talked about changing the way people eat, removing toxins from their body, taking certain nutrients, medications, extensive blood testing. And guess what? That was published 4 years later. And I presented this slide last month. 100 people with mild cognitive impairment, early stage Alzheimer's, had it reversed using the very technologies that were described 4 years ago. Now, if someone was listening and they were experiencing some mild cognitive impairment, they could have logged onto that website. Sharp Again Naturally is the name of that group, Sharp Again Naturally, and they could have read the protocol. It was relatively easy to implement, but it required very strict dietary practices. And if they didn't pay attention, they would have declined to the point where at this stage they may have been truly irreversible. But what the media tells you, and even what the scientific community relays, does not always relate to reality. And we know this. We know this because we see it before our eyes. And then the December 2018 cover of Discover magazine, they published an extensive article on the very protocol those 3 women from that charitable group, Sharp Again Naturally, described on this podium in November 2014. So if you keep your nose to the grindstone from the standpoint of paying attention to published scientific information and the people who happen to know a little bit more than that, you can spare yourself some horrendous horrendous problems. This is the opening article in that December 2018 Discover magazine. They interviewed a number of people who had been demented, and they were no longer demented. They were restored to varying degrees of functionality. In some cases, people who were in kind of a senior citizens care facilities, they were able to regain their independence, go back to work, go back to living by themselves, going back to be able to take care of themselves from a personal hygiene standpoint and cook their own food. This happened. So when someone says something is irreversible or impossible, often they're simply wrong. They just don't know where to go to get the information. And I don't claim to know where all the information is. I was just introduced to this charity back in year 2013. I said, well, this is fantastic. I reviewed all the protocols. It made scientific sense. I said, well, why don't you put on a presentation? And they volunteered their time to do that, to spare humans the indignities and the eventual death caused by Alzheimer's. A terrible situation. But what we aim to do is reverse biological aging so that if a person is suffering some pathology in their brain, we can potentially reverse that and restore them back to a more youthful functionality. This is a revised stair-step approach, a sequential order of biological age reversal techniques. Now, the previous version of this listed a drug called rapamycin as the #1 priority, and we still think it may be. Problem is, the dose that we've used in some clinical studies may be too low to give us the results we're seeking, because what we're seeking to do is suppress a protein in your cells called mTOR, stands for mechanistic target of rapamycin. Most of us are overeating and not taking care of themselves. Elevated mTOR accelerates aging. Turn down mTOR, you slow and reverse aging. So what we're advocating people do until we identify the ideal dose of rapamycin, it's 5 milligrams a week. And if you're taking that now, it's okay. No toxicity, no problem. It's just not giving us the results we're looking for. We're going to advocate what I've talked about since 2013, and that is metformin, an anti-diabetic drug that has AMPK activating properties that then indirectly suppress mTOR. And add to that metformin some intermittent fasting, some calorie restriction, different types of compounds that boost AMPK, a number of them are out there. Suppress that mTOR, move up to restoring some of your NAD, and then your cells are ready to start to be selectively removed. I'm talking about your senescent cells that are prevalent throughout our aging body and are a major factor in degenerative aging. And the senolytic protocol that we recommend is a drug called dasatinib and a nutrient called quercetin. Just use it 2 times a year and you will purge your body of lots and lots of senescent cells. I've spoken about that in many, many forums. That has demonstrated a 90% efficacy rate in people with severe bone-on-bone osteoarthritis, and we're getting confirmatory data, people using other senolytic compounds also seeing arthritis virtually disappear. And arthritis is the primary target. Reversing arthritis and inducing cartilage regeneration, we think we're also inducing systemic regeneration. Now, this stair step goes up to year 2030. This is where we need to live to in order to take advantage of CRISPR-Cas9 gene editing technology. That is likely to be the ultimate cure for biological aging. Once that's perfected, and they expect to have it perfected in about 12 years, people will no longer die from aging. But there'll be other issues, so we hopefully have aging taken care of by year 2030. And then we want to make sure we control our risk of a lot of diseases, accident prevention. We have to really take care of ourselves, because what a number of experts are stating, if we make it to year 2050, we may be able to merge with the cloud. The singularity is going to give us the capability of achieving physical immortality, the idea of mankind creating technologies that will facilitate the transformation of life into an era of perpetual abundance. And abundance is the topic really I'm going to talk about during this lecture, because this is the holiday season. We have these nice bright lights, and we might assume that that's the way it used to be in the past. We often romanticize the past as a time where people were having a lot of fun and it was cheery, very illuminating. But that's not really the way it was. Unless you had a lot of money, you could not afford candles, you couldn't afford whale oil, you certainly couldn't afford petroleum because they hadn't figured out how to even pull that out of the ground yet. So instead of having a bright lit situation, in reality it was rather dull. This is for the wealthy people. The wealthy people who could afford to burn down those very expensive candles made out of precious animal fat. And basically you were starving people to make an expensive candle so you could have light. And there were so many food shortages back there. People literally starved to death while they were using the animal fat for candle wax. But for most people, when that sun went down on Christmas Eve or any night, well, you just went to sleep. You just went to sleep. I mean, there was nothing. It was totally dark. No light, no energy to produce the light. You just waited till the sun rose. That's the way it was. And we take so much of that for granted. And the cost of being able to even light an oil lamp was so prohibitive that people just weren't doing it. They couldn't afford to do that. Buying a gallon of fuel, if you can imagine paying a half a week's salary. And people ask about cryonics and future costs. Costs are going to come down. It's going to get real cheap at some point to revive cryopreserved people. So we're not really worried about that. And this is what I'm going to try to analogize here with this presentation. For thousands of years, no one believed that you could drill a hole in the ground and pump out petroleum. People wanted it. They wanted to use it for lighting, for various energy and heating purposes. It was just too expensive. It was considered impossible by all the experts except an individual named Edwin Drake. He thought that if you properly drilled a hole in the ground, that you could potentially extract petroleum and pump it out and ship it to other places. Almost everyone thought it was nuts. A few people put some money in, but they even gave up. But Edwin Drake, he persisted. He persisted when investors withdrew, when people ridiculed him, when he failed, by the way, many, many times. Almost every attempt he made to erect an oil drilling rig and pump that oil out, it failed for technical reasons that you might think don't make a lot of sense. But read it up on the internet. Just check on the internet about the history of oil drilling and you'll see how challenging it was. Drake, by himself, may have been the only person in the world who thought this was possible. Well, he persisted, and guess what? 1859, he strikes oil. He shows that you can pull oil out of the ground. And I know that sounds simplistic right now. You think, yeah, anyone could have done that. Not the case. Very, very challenging. And that petroleum led to the Industrial Revolution, which has led to many other revolutions that we're enjoying today. But you look how fast technology advances once something is proven to work. So 1859, August, the first oil well produces oil. And by 1860, they're loading it onto ships in western Pennsylvania and moving it to Pittsburgh, Pennsylvania, to use in different industries. Oil was a big factor in Pittsburgh's industrial growth. And an oil well was producing 300 barrels a day. That was a world record. 5 months later, in 1861, it's 4,000 barrels a day. And analogize that to what we're trying to do as far as longevity. We're seeking to live to be 130, 180, 300, forever. Well, once the technologies start to evolve and we understand more and more about the biosciences, longevity enhancement, it's just going to happen because there'll be money to be made. There'll be curiosity. There'll be people like me who just want to do it, and we're going to make that happen. And 1861, the United States is the first country to export oil to London. Think about that. This country was the one that did it, and oil is a big reason why this country continues to enjoy economic dominance. So we should pay a tribute, and I know environmentally this may not impress you very much, but these forms of energy are going to be dissipated over the next 30, 40 years. There'll be other ones. A little bit of a tribute to a guy named Edwin Drake who persisted when everyone said it can't be done, investors pull their money out, and he just keeps at it. He doesn't give up. And this is the secret of success, by the way, of every pioneer. They're humiliated, they endure persecution, sometimes they're executed, but they don't give up. And when people talked about cost and concerns about cryonics, look what happened when oil drilling technology advanced just a few years after. It was $10 a barrel in the beginning. $10 a barrel. Within 1 year, it goes down to 10 cents. So if you think $28,000 is insufficient to revive you, it may be, but guess what? There are multi-billionaires who have set up revival trusts. Dennis didn't mention this, but very wealthy people are taking their money with them. And they specify in those trusts to fund research, fund reanimation, do all kind of good things. So the money's going to be there, even if the people with only $28,000 are going to have to wait a little bit longer. So, but this is an example of something that was very expensive becoming cheap real fast just because technology advanced. And offshore drilling started in California. It was a big part of California's success. They start from the beaches, drill it out into the ocean, but they were afraid to go out beyond the sight of land because it was very dangerous. Again, this is 1901. In 1859, Edwin Drake, for the first time, shows you can, from the ground, drill down and pull up oil. They're going out into the ocean. And by 1947, less than 100 years later, they've got these huge oil derricks, thousands of them around the world, going tens of thousands of feet down into the ocean, pulling up oil. And again, this may just sound like that's an easy thing to do. It isn't. It takes a lot of technology. But that kind of technology, if that evolves with biomedical sciences, guess what? We're going to live forever. We are never going to die if biomedical science advances at this rate. And you look at some of the hiccups that come along the way. Hey, we've all been around, almost all of us. 1973, sitting in line, waiting 2 hours to fill up your tank with gas. And in the 1970s, every single expert stated there is only a limited supply of oil left. By around the year 2000, it'll all be gone. The world's going to turn dark again. We're going to return to the Middle Ages, and there'll be no hope for civilization. This was universal. There was not one person who said, we're not going to run out of oil, because there's only supposedly a limited supply, right? If there's only so much of something and you're pumping it out real fast, it's eventually going to run empty. Well, that wasn't the case. That wasn't the case. An individual named George Mitchell. This is another hero from the standpoint of looking at a problem and saying, I think I can figure a way around that. He started in 1994 with some advanced concepts that, again, environmentally, I know people don't like it, but fracking and horizontal drilling, all kinds of advanced techniques that he was involved in the early years, and it worked. Despite everyone saying you couldn't access those types of oil deposits, he figured out a way to do it, became a multi-billionaire. Fortunately, he died year 2013, was not cryopreserved, and as far as I know, just didn't follow some of the aggressive lifestyles that we do. So, December 6th, a couple days ago, Wall Street Journal, United States of America becomes a net exporter. We're just like OPEC right now. We're exporting oil and making money at it. Now remember, we were supposed to run out of it by year 2000. And even in 2005, the prospect was 30 or 40 years, we'd be out of oil. Instead, technology improved. And what was unthinkable just 10 years ago is occurring every single day in this country. We're exporting oil. We'll never run out of it. So the impossible happened during our lifetime in an area that was challenging. And I'm telling you, you're going to see some incredible advances in the biomedical arena, and I'm intimately involved with a number of these. We're seeing these incremental improvements. And at some point, once we reach a level where we're inducing meaningful age reversal, we're going to see people living a long time in a great state of health. And this shows you, starting in 1920, the oil production, and how in 1970s it peaked in this country. People thought it was just going to go down to nothing, to zero. And in reality, we're pumping more now than we were in 1970. We've literally reached a point of reversing this terrible decline. So for anyone who thinks life in the olden days was somewhat better than it is now, this is the book that I always recommend you buy. Just go to Amazon, get it for a couple dollars used. The good old days, they were terrible, because in contrast to today, they were. Just from a medical standpoint, think about esophageal reflux, just chronic heartburn pain. A lot of our founding fathers suffered from that, by the way, and there was no antidote for it, really. You just suffered. You suffered. Impacted wisdom tooth, you just suffered. I mean, it was horrific. Think of the chronic problems that pretty much I think we've all suffered from in this room, certainly myself. And there was a medication there for me to get rid of that chronic problem. They didn't have it back then. They also didn't have good lighting. They didn't have much of anything. And yet people somehow think it was better back then. The pollution, by the way, back then was beyond description, beyond it. The streets filled with horse manure, open chimneys, burning coal, wood to keep the house warm. It was a miserable existence, and yet we persisted. So we take for granted what we're enjoying right now. We think it was always available, easy to obtain. No, it took a lot of pioneers to give us what we have right now. But because of those pioneers, we now have the ability to carry that ball forward in the biomedical field, which is what our priority is. So we don't have to live in darkness anymore. We have technology to reverse Alzheimer's disease, and yet virtually nobody knows about it. So when you wonder what this is for, it was to take advantage of everything I talked about for the last 15 minutes and transform our existence into eternal abundance. Unlimited supplies of resources, unlimited wealth, huge improvements in human longevity to the point where mortality will be an option. If you want to live 300 years, that's up to you. If you want to live for an indefinite period of time, again, that option will be available. If anyone has any direct questions for me, I'll answer them.
Human age reversal. We may be there already. Human studies are now ready to begin to confirm meaningful reversal of pathological aging processes. These clinical trials aim to alter older humans so that they function as much younger individuals. Even modest success will result in a paradigm shift that will impart enormous societal benefits, such as sparing Medicare from insolvency. Life extension is not standing idle while 5,000 Americans die each day from age-related illnesses. Joining us are physician scientists who want to hurry up these technologies to keep people from aging to death. While life extension is pushing these projects forward, we need financial help to ensure these studies are carried through to fruition.
Carrier asks, what does comfort mean to you? Is it a cool breeze on a scorching day? Or a cozy corner on a cold night? That every room of the house is as inviting as the next? And the air is fresh and clean for everyone? That humidity is where it belongs? At Carrier, comfort means more than just the temperature. And the people who invented modern air conditioning keep inventing new ways to make you comfortable, however you define it.
This concludes our special report from Bill Faloon. I'm Richard Peritz. Thank you for being with us.